Alright, ladder 7. This is our controls ladder. And controls is the heart of this program. So this is going to be a longer lecture. This is going to be a lot of logic. This is going to be a lot of explanation. So please expect to have to watch this 2 or 3 times and possibly have to jump back to a couple of other lectures in the program walkthrough in order to follow exactly what's going on throughout this ladder. That's okay. That's part of the learning process. The goal here isn't to watch every lecture exactly once and become a PLC programmer. The goal here is to understand, to retain all of this information and understanding, and then become a PLC programmer. So, starting at rung 1, and there's a lot of logic going on here. The first thing we want to do is let's look to the right and see what is this rung actually trying to accomplish. We have N74 designated as our system mode, and our system has 3 modes. Our system is either off, it's on, or it's faulted. And in this case, since we're moving a 1 into that integer location, that tells us that this is the rung that's turning our system on. So when does our system turn on? Well, we're going into the on mode. First of all, if the on button, which is a physical push button, an actual input tied to this bit, if that push button is pressed and our system mode is currently in the off mode, you see we're looking at N74 and we're looking to see if it's equal to 0. So if I push the on button and we happen to be off, then we're going to one shot, which means this is only going to happen one time. We're going to turn our system on. And there's another possibility. You see, aside from the physical push button, we also have a system on push button bit, which is on the HMI. So aside from a physical button, on our screen program, we also have a push button that's also called on. And if we push that button while the system is off, it'll do the same thing. So we have a choice of 2 different buttons we can use to turn this thing on. There's one other possibility that's going to put this system into the on mode, and that is if I push the alarm reset button when we are in mode 2, which is faulted, then we're going to move the system mode to the on state as well. Now what that means is whenever we have an alarm condition, the system mode is going to be changed into a faulted mode. That means it's still running, but perhaps with limited functionality, and there's certainly a condition that the operator needs to be aware of. But once we reset that alarm here, then we're going to go ahead and put it back into the normal on position with the understanding that if the alarm condition remains, it's going to be thrown back into the faulted state automatically. So, rung 1, this is also setting our system mode, and it's setting it to 0, which is off. So this is where we're turning our system off, and we're looking for one of 2 things to happen, quite simply. There is a physical button on our enclosure. There is also an HMI push button on our screen program, which does the same thing. And regardless of mode or anything else, if somebody pushes one of either of these off buttons, this one shot will become true for exactly 1 scan, which is all we need to move 0 into the N74 integer location, and that has turned our system off. And then we come to rung 2, and this is moving a 2 to N74, which means this is what's putting us in our faulted condition. And all we're looking for here is a general alarm notification bit. And that bit is energized in our alarms ladder, which we'll cover in a subsequent lecture. And that is energized anytime we have any alarm. So once we have an alarm, then we're going to one shot and we're going to set our system mode to faulted. Now, you remember above, if we press the alarm reset, then we're going to leave the faulted condition and go into on. However, we're also going to reset the alarm and this notification bit. But once we let go of that, if that alarm comes back, then we're going to one-shot again and we're going to throw ourselves back into faulted. So you can run from the alarms, but you can't hide. Now we come to rung 3, which looks complex, but it's really not, and it's actually a rung you've seen in a previous lecture. This is setting our blower mode. This is HOA control. We are moving either a 1 or a 0 or a 2 to the N711 position, which is what we've designated as our blower mode. And we can see from this description of N711 that 0 is equal to off, 1 is hand, and 2 is auto. We have 3 push buttons on our HMI, no physical push buttons this time, and we're looking for a hand push button, an off push button, or an auto push button to be pressed. And if any one of those is pressed, it'll trigger a one-shot. And remember, each one-shot has its own address. So if we search for B3211 and run a find all, we're going to see that we only have that showing up one place in the whole program, and that place is right here. So each one of these will one-shot and cause a different value to be written into N711, thus changing the mode of our blower. And as a refresher of HOA, we already know off means the blower is off and it never comes on. Hand means the blower is on and it stays on. And auto means the program can control the blower and turn it on and off as required. Dropping down to rung 4, here we are energizing our blower. And remember, this is the bit that's tied in our digital outputs to the blower in ladder 4. And we have 2 different times when we're going to be energizing our blower. The first one, we're looking at N7-4, which is our system mode, and we want our system mode to be not equal to 0, which means we can be in the on mode or we can be in the faulted mode, but we cannot be off for this branch to energize the blower. What else we're looking for is our blower mode has to be in auto. So anytime our system is either on or even if it's faulted and we're in auto mode, this blower is going to be running. The other thing that will start the blower is if N711, our blower mode, is equal to 1, which is hand. In that case, the system can be off, on, or faulted. We don't care about the system mode anymore. If somebody turns the blower into the hand position from the HMI, the blower is going to run independently of everything else. Now, on rung 5, we're not controlling the blower anymore. Now we have a tank and we're controlling its filling. So this is going to look similar to our previous example from another section when we were looking at control logic and alarms and we were programming a tank. Now we have our system mode, and we're looking for our system mode to be anything other than off, which means it can be either on or faulted. And as long as our system is not off, we're going to go ahead and proceed to check our tank level. If our tank level falls below 20%, and remember, when we're looking at any analog signal, we generally have a low-low, a low, a high, and a high-high. Low-low and high-high are alarm levels. Low and high are process control levels. So if our tank level is less than some level, which in this case is 20, that tells us that 20 is our low level. And we're actually not using 20 as a hard-coded value, but we're referencing N7:1, which is an integer location, meaning that's a set point. Perhaps we can put that set point onto an HMI, and the operator can decide what level he wants to use to trigger fill mode. So back to this rung, as long as our system is not off, and if our tank level is less than N7-1, which is our low set point, which is currently 20%, and as long as nobody's pushing the alarm reset button, then we're going to energize our tank fill start delay timer, which is a seconds timer with a preset of 5. So this is a 5-second timer, and once that timer times out, we're going to one-shot and we're going to fire this tank fill trigger bit. And since that's a one-shot, that means that this trigger bit, is only going to be energized for one scan. Now we could just as easily replace this OTE and this ONS with one OSR. But this is here this way to show you that there are many roads to Rome, and certainly this is another one. And just like we have a tank fill trigger rung, which is the purpose of rung 5 is to trigger tank fill, rung 6 is going to be used to trigger tank drain. And these two rungs look an awful lot alike. So what are we looking for first of all? We still want to make sure that we are not in the off mode. Our system is at least running, even if it's running with a fault. This time we're looking for our tank level to be greater than N7-2, which obviously is going to be a high set point. And if we hover over that with our mouse, we see that it says it's actually tank SPH, which is tank set point high. And if we're over that 80% and nobody's hitting an alarm reset button, then we're going to energize our tank fill stop delay. This timer is also a second timer with a preset of 5, so it's a 5-second timer. We're going to energize our down bit after that 5 seconds expires, and we're going to one-shot our tank drain trigger bit. Now our next two lines of code are actually handling our filling and draining of our tank. And right off you'll notice these two rungs do not look the same. So there's some different action going on between them, and we're going to see why. First of all, on rung 7, we're looking for our system mode to be not equal to 0 again. So we want to make sure that we're in any system mode other than off. And once we get our tank fill trigger bit, we're going to check to see if we have a tank fill pump alarm notification bit, which is energized in our alarms ladder anytime we have any kind of alarm with the pump. So this is actually a categorical alarm bit, and this is energized by several different conditions, as we'll see when we get to the alarms ladder in a subsequent lecture. So as long as our pump is okay is basically what this instruction is saying, and as long as our tank level is not high. And here we're looking at a tank level high alarm bit, and this is an XIO command, which means examine if opened, just like this one. So as long as neither of these two things are true, we're going to go ahead and energize our tank fill pump. And this bit B311 is tied in our digital outputs ladder directly to the pump. So once we get the tank fill trigger bit, as long as there's not a problem with our pump and as long as our tank level's not too high, we'll go ahead and energize the pump. Now the pump is going to need a hold-in to bypass the trigger bit, and it's going to be its own hold-in. So you see we're looking at B311, which is the same output we're energizing in this rung, and we're going to go ahead and retain it until we get the tank drain trigger bit. And once we get that tank drain trigger bit, which was energized by this second timer here on rung 6, then we're going to break the hold-in and de-energize our pump. And in this case, we're not actually running our tank by filling and draining, and using a pump opposite a discharge valve. In this case, we're running a supply valve but we're trying to keep that supply valve open all the time. So the first thing we're doing to energize that valve is we're checking our system mode, of course, to make sure that we're not in the off mode. And then we're looking at our tank level low alarm to make sure we're not low. And as long as our system is not turned off and our tank is not low, we're going to go ahead and energize the supply valve. And this logic is pretty standard of a water supply system. We're going to be using a pump to fill up the tank when it gets low, and we're going to rock that back and forth between a low and a high level. But we want our supply valve open all the time because people always want to be able to use water. So even if that supply valve is open and everybody's using the water, we're assuming here we have an appropriately sized pump which can fill the tank faster than that supply valve can drain it. So the only time we'll ever shut that supply valve off is 1, if we turn our system off, or 2, if our tank actually gets down to a low level, in which case then we'll shut the supply valve to prevent people from getting sediment in their water. Moving down to rung 9, now we're getting into heater control. So we're past our logic for our blower, we're past our logic for our tank. Now we're looking at this heater, and anytime our system mode is not equal to 0, again, we're either in on or faulted mode. As long as we don't have a high temperature alarm, then we're going to go ahead and energize the relay to our heater. Now remember, this heater is using 2 signals, a digital and an analog. The digital is basically just telling it it's either on or off, and the analog is telling it to heat and how much to heat. So as long as we're not off, and as long as we haven't blown up our heater with a high alarm, that relay is going to go ahead and be energized, in which case rung 10 is going to be sending it an actual signal to tell it how hot to run. So at the beginning of this rung is our familiar system mode is not off condition, and as long as N74 is not equal to 0, we're going to come to the right and do 2 things. The first thing we're going to do is we're going to take an integer location, N76, and we're going to move that to this other location, PD9:0.SPS. Now what is all that? Well, if we hover over N76, we see it says temp_SP. That's going to be our temperature set point. That's where we want our temperature to be, and that's going to be set from the HMI. So the operator is going to walk over to the screen, and he's going to have a numeric input which allows him to change a number, and that number is going to be written to N76. So if it's 68 degrees in the house and we decide, well, we want to heat it up to 72, we're going to walk over to that, click on it, and type 72, hit enter. So that entry is going to come to this block where we're going to move it into PD9, which is our PID data file, and we're going to be storing that as the set point for this PID control loop. And this PID control loop is looking at N78, and N78 is our scaled temperature coming in from an analog input, and we're going to be controlling N79, which we are writing out to an analog output to the heater. So this PID is going to be controlling N79, the analog output to the heater, to make N78, the analog input from our temperature sensor, attain and maintain our set point from N76, which is currently set to 90. And moving down to our last rung in this ladder, rung 11, we're energizing an alarm horn, very annoying. That's tied to an output, obviously, in our digital outputs. And what we're looking for is our system mode to not be equal to 0, which means anytime our system is on or faulted, if there is any kind of alarm, which is going to be read by this general alarm notification bit, then we're going to go ahead and sound the alarm. So that's going to be very annoying until the operator resets the notifications or silences the notifications and gets rid of that bit.